Hello. Here is a review on linear function and a couple of other things. So this is why it's titled and some more. So we're going to review very briefly linear functions. We're going to talk about evaluating a function, and we're going to talk about the average rate of change as opposed to slope. Okay, so the three forms of a linear function. So the first form, the one that you're probably the most familiar with, is called the slope-intercept form. And the slope-intercept form, as its name indicates, is going to give you the slope and the intercept just by looking at it. So the form will be y is equal to mx plus b, and the b stands for your y-intercept and the m stands for your slope. Maybe I should write that down. This will be the y-intercept, and the m will be your slope. The next form of a linear function will be what we call the standard form. And that will be ax plus by is equal to c, where a, b, and c are just real numbers, right? Just values. It could be a positive value, it could be a negative value, it could be a fraction, right? But they're real numbers. And this equation really doesn't give you anything just by looking at it. Just like the one above, by looking we would know that whatever number is here will be the y-intercept, whatever is here will be the slope. This one doesn't, but it will give you some indication about the x and the y-intercept by doing just a little bit of plugging in a zero, which we're going to look at later. Okay, and then the third form of a linear equation will be what we call the point-slope form. The point-slope form is the one used the most in upper-level math classes. And it's, as its name indicates, it's an equation that just by looking at it, you will get 1 point on the line and the slope. And that would look like y minus y1 is equal to m parentheses x minus x1, and x sub 1, y sub 1 will be a point. On the line. And of course the slope is m, just like above here, so this will be your slope. That hasn't changed. Alright, so those are the three forms of a linear equation. So now, how can we find the slope when we're given 2 points? So if we're given 2 points, I'm going to change colors. If we're given 2 points, I'm going to call this x1, y1, just for the first point, and x2, y2 for the second point. It doesn't really matter which one you pick as your first point, which one you pick as your second point, as long as you're consistent when you set up your formula. So the slope formula says, so it's m is equal to y2 minus y1 over x2 minus x1. So the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So what I meant earlier by saying it doesn't matter which one you pick as being your first point or your second, as long as you're consistent, was that whatever y value you put up here, the x that's below has to be the x that corresponds to that same point, right? So for example, I wouldn't put this y value first and then this x value just below, right? Because they're not belonging to the same point. That's what I mean by being consistent. The y's also have always are always in the numerator, right? You always have them at the top there, and the x's, the difference in the x's is always in the denominator, so at the bottom. All right, so let's find the slope for those 2 points that are given to us. So m will be equal to 13, right? y2 minus y1, so that will be 13 minus 1 divided by x2, which is 5, minus x1, so 5 minus 2. And now it's just a matter of simplifying the numerator and the denominator. 13 minus 1 is 2. 5 minus 2 is 3. And then you have to keep going and simplify as far as you can. And 12 divided by 3 simplifies, so that will be 4. So the slope between those 2 points will be a slope of 4. Alright, here we have 2 different points, so let's change color again. So I'm going to use this as my x1, y1, this as my x2, y2, and then my slope will be equal to the y2, which is negative 8, minus my y1, which is a 4, divided by the difference between x2 and x1, so 4 minus 0. Negative 8 minus 4, that's a negative 12, and 4 minus 0 is 4, and that will give me a slope of negative 3. So what is the difference between this one and this one? This slope is positive, therefore if I'm looking at this line from left to right, that line will be going up by 4 over 1. This one, if I will grab those 2 points and draw a line between them, from left to right, that line will be going down because it is a negative slope. Okay? Now, how do we find the slope from a graph? So here we did it given 2 points. Now we're going to do it from a graph. So here is my first graph. So if I need to find the slope of this line, the first thing I need to look at is I need to find where this line goes through a corner point of my grid. That might be hard for you to see, but hopefully you could pull up this picture on the computer and see it a little better. But right there I'm going through a corner point of the grid, and then I am going to keep following my line until I'm in a corner point again, and right there I will be at a corner again. And now I'm going to count. So from this point to that point I'm going to go toward the left, so I'm going to go up first and then over 1, 2, 3. So up 1 over 1, 2, 3. So the slope for this one will be up 1, so a positive 1 over 3. So the slope will be 1 over 3. For this line, you're going to do the same scenario. We're going to look at the corner point first, and it looks like I have one right here. And then I follow my line toward the right until I hit a corner point again, and that will be one there. And now I'm counting. So from the point most to the left to the point most to the right, I'm going to have to go down 2 first over 1, down 2 over 1. So this slope down 2 is shown by a negative over 1, but we don't need that division by 1, right? So that's just going to simplify to a negative 2. So the slope of this line will be negative 2. Alright, so when we are given an equation this time, how do we find the slope? Well, if the equation is in the format slope-intercept form, y equals mx plus b, then it's easy. We just look at whatever is in front of x, and that will be my slope. So when I'm looking at f of x here, I have the equation is given to me as x over 4 plus 1. Well, this is really the same thing as 1/4 x plus 1. And if I do realize that, then the m, what's in front of my x, will be 1/4. So here, the slope will be equal to 1 over 4, meaning this line, f of x, goes up 1 over 4. Now, for g of x, if I wanted to find the slope, well, I have a little bit work to do, right? Because I am not in the point slope, in the slope-intercept format here. And I am not in the point slope form either, really. So I really have to be careful and do a little bit more work. So I'm going to distribute this fraction. So g of x is equal to negative 1/2 times 5 is just a negative 5 over 2, and then the x. And then negative 1/2 times positive 6 will be negative 1 times 6 is 6, and 6 divided by 2 is 3, so that will be negative 3. Now this is in the slope-intercept form. So now by looking at whatever is in front of my x, that will be my slope. So what's in front of x will be negative 5/2. And so the slope here will be negative 5/2, meaning if I would graph this line, the line will go down 5/2 for the slope. All right? Now we're looking at this equation, and this equation is in standard form, right? Now remember, the standard form doesn't tell me anything about the slope, so I have to do a little work, rewrite this so it looks like this format. So I want to get my y by itself. So to get y by itself, I need to subtract 2x first from both sides. And so I'm going to have negative y is equal to, I don't like my x term behind the constant, so I'm going to sneak it in the front here, and I'm going to say that's a negative 2x, and that was a positive 7, so plus 7. And then I need y completely by itself, so I need to divide by a negative 1 all the way through. So divide by negative 1, divide by negative 1, divide by negative 1, and I don't have room below, so I'm going to go to the side here, and I'm going to say negative 1 divided by negative 1 is a 1, so that's y equals negative 2 divided by negative 1 becomes a positive 2, so 2x. And then positive 7 divided by negative 1 becomes minus 7. And now I am in the slope-intercept form, and I can look at what's in front of my x, and that will be a 2. So the slope here will be 2. So this line will go up 2/1. This equation, if you pay attention to the three forms you have, will be in point slope form, because I have my y minus a number, which is my y1, equals something which will be my m here, and then the x minus a number, x minus a number. So you're going to say, well, why was this here not earlier in point slope form? Because this y could just have been a 0 maybe. Well, it's because we had a coefficient in front of the x, right? X was not just by itself, like here. There was a coefficient, so that was not the point slope form. So we had to do a little bit of work here. We had to distribute this fraction in the front. But here we don't, because x is by itself, there is no coefficient in front, and so we are in point slope form. Therefore the slope will just be whatever is in front of the parentheses. So here the slope is going to be equal to negative 2/3. So this line will go down 2/3. Alright, so that's for slope. Now, evaluation of functions. So if we are given functions and we are told to evaluate them for a specific input, what do we do? Well, f of x is given to us as being the negative absolute value of 2x minus 1 and then plus 3, and we need to find f of negative 3. That just means that wherever we have an x, we need to replace it by a negative 3, right? Notice how f of x became a negative 3 here. So same thing on the right of the equal, wherever we had an x, we're going to substitute by a negative 3. So f of negative 3 is equal to negative absolute value of 2 times x, but my x is now negative 3, so 2 times negative 3 minus 1, then close the absolute value and plus 3. So close the absolute value and plus 3. And now it's just a matter of doing the computations, right? Do the math. 2 times negative 2 is negative 4, and negative 4 minus 1 is negative 5. So that becomes negative absolute value. This here we just said was equal to negative 5. Close the absolute value and then plus 3. All right. The absolute value of negative 5 just becomes a positive 5, so that becomes, we still have that negative in the front here, so that stays. Absolute value of negative 5 becomes a positive 5, and then plus 3. And so now we have a negative 5 plus 3, which is negative 2. Alright? Change colors. G of x is equal to 2x over 1 minus x. So here I gave you a function that's not linear, purposely, just so that we can see different scenarios, right? The idea is the same. I'm given a g of x function and I need to evaluate g of -1. That means that wherever I used to have an x, I need to now replace that x by a -1. So I had an x here and an x here. Both of those x's have to be replaced by -1. So g of -1 is equal to, we had a fraction, and we have 2 times x, but x is now -1, so 2 times -1. And then it was divided by 1 minus x, so 1 minus, and x becomes -1. Okay, now we just simplify. Numerator first. This is a multiplication, so 2 times -1 is -2, divided by 1 minus a -1, so 1 minus negative becomes plus, so 1 plus 1 becomes 2, and -2 over 2 becomes a -1, so this is -1. So g of -1 is actually equal to -1. That wasn't done purposely, that they end up being the same, being the input and the output, but that's just what happens sometimes, right? All right, here we have a function h of x, and again, it's not linear, but it's just for illustrating what we do. It works the same for all type of function when we evaluate function. If you're given a function rule, this is what we call a function rule, you're given a value to evaluate it at, you're just replacing all your x's, so this one and this one, by the value that's given to you. So h of 10 is equal to, and we're going to replace this x by a 10, so parentheses, 10 minus 2, close the parentheses, square, and then plus 3. And now we're just evaluating that. So 10 minus 2 is 8, square it, plus 3. 8 squared is 64, and then plus 3, and that will be 67. So h of 10 is equal to 67. All right, the last idea we're going to look at here, well, at least on this paper, is if you look for an average rate of change. Now, you want to be familiar that in math, we kind of like shortcuts when we have to write long things. So average rate of change is very often written as AROC. A for average, R for rate, O for off, C for change, AROC, right? So the average rate of change of h of x being the square root of x plus 2, and then a minus 3 in the back. An average rate of change is a slope when your function is not linear. So what do I mean? I'm going to graph that to show you. So this here will be, I'm going to have to make sure I have enough room. So x plus 2, I'm going to go here, and I need to go down 3, so that will be right there. And then this graph here will be, okay, I'm going to kind of, okay, it's not perfect, right? I have a little kink here, but it's kind of like that. It actually bugs me a little bit, so let's see if we can fix it, make it nicer. Maybe. Okay. This graph, if you would put this in your calculator, that's what you would see, right? So what does it mean to find the average rate of change? Well, that's obviously not linear, it's not a line, so we can't find the slope. Slopes are only for lines, right? Straight lines, that's when we can find slopes between 2 points. But sometimes we just want an average, and that's when we're going to do what I'm about to do here, the average rate of change. So the first thing we need to figure out is average rate of change. Just like for slopes, we need 2 points, right? So the average rate of change between which 2 points? And they're telling us between x equals 2 and x equals 7. So x equals 2 will be, 2 is right there, 3, 4, 5, 6, 7, and 7 will be right here. So between those 2 points. So I want the average rate of change between those 2 points, and it's not going to be perfect, but it's going to be very, 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 very close to my curve here. And so the first thing I want is I need to figure out what those y values are. Well, I have the graph here, so I could just read them from the graph. Or if I didn't have the graph, I would just evaluate my function at 2 and evaluate my function at 7 and then figure out what those y would be and do a slope formula. So let's imagine we don't have the graph, and let's do that. So I need to find h of 2 first. So just like we did above here, we are going to replace the x with a 2. So that will be the square root of 2 plus 2 and then a minus 3 in the back. And so h of 2 is equal to 2 plus 2 is 4, square root of 4 is 2, and 2 minus 3 is negative 1. So really what we're saying here is that for x equals 2, we would have a y value of negative 1, and that would be my first point. So let's check from our graph. When we have an x of 2, the y value will be negative 1. So that matches our graph, right? So now let's see what happens to the 7. Again, let's imagine we don't have that graph, and we have to evaluate h of x at x equals 7. So we're going to replace the x's by a 7. So let's do a different color. So we're going to say h of 7 is equal to, and replace that by a 7. So square root of 7 plus 2 and then minus 3. So h of 7 equals 7 plus 2 is 9, square root of 9 is 3, and 3 minus 3 is 0. So what this shows us is that when x equals 7, the y value will be 0. So now let's check on our graph to see if we have a point at 7, 0. So we go 7, 0, and sure enough, we are on our curve, right? So we want the slope between those 2 points, and now we're going to just do the slope formula. Again, we have a graph, so we could use the graph and count and say the slope is going to be up 1 over 1, 2, 3, 4, 5. So let's remember that. Let's check that in a minute. So the average rate of change will be up 1, 1, 2, 3, 4, 5. So we're saying it will be 1 over 5. Remember, I say average rate of change, not slope, right? Because this is not a linear graph. It's curvy, so it's not perfect, it's an average. All right, so let's do that. So the slope between those 2 points, so the slope, if I would draw a line between those 2 points, would be m is equal to, so y2 minus y1, so 0 minus negative 1, over x2 minus x1, so 7 minus 2. Negative negative becomes a positive, and 7 minus 2 is 5. And so the slope between those 2 points is 1/5, and the average rate of change we said was 1/5 by looking at the graph. So that's what that would be. The average rate of change of h of x between x equals 2 and x equals 7 is actually 1 over 5. All right, so we have a few more things to look at about linear functions. And that is writing a function when you're given a graph. So how do we do that? Well, when you're given a graph, you can pick, if it doesn't tell you, you can pick whichever form of the equation you want, right? You can pick slope, intercept, standard, or point slope. Well, if I'm given a graph, I probably look for y equals mx plus b first, because I could look for the y-intercept on the graph and count between 2 points to find the slope. So let's try that. So when I'm looking here, my very first point I'm going to pick is here, and then I follow my line until I hit a corner point again, and that will be right here. From here to here, I would have to go up 1 over 1. Up 1 over 1 tells me that my slope is just going to be a 1, right? Up 1 over 1 simplifies to 1. And then the y-intercept, well, that's where the graph crosses the y-axis. Well, that will be right here. For what value is that? And that will be for x equals 0. So the y-intercept, which is my b value, is 0. I have all I need to write this equation. That will be y equals mx plus b. So we said that the m is 1, so 1x, and the b we said is 0. Well, we don't really have to write that like that. We can simplify, so that would just be y equals x. Because 1 times x is just x, right? And plus 0, it doesn't matter. All right, let's try this one. So again, I need my slope. So I'm looking for a point, follow my line until I hit another corner, and right there is one. And to go from left, don't count ever from right to left, right? We always count from left to right when we read the graph. Just like when you write in English, right? You start on the left, you go toward the right. And so from the point most to the left to the point to the right, I'm going to go down 1 over 2. The down motion is going to be shown by a negative, so the slope will be down 1, negative 1, and then over 2. So this will be my slope. The y-intercept I can read from the graph is right here, so the y-intercept will be negative 1, so that will be my b value, and so the equation will be y is equal to negative 1 over 2x, and then minus 1 for the b, so that's my equation right there. Okay, this one, when I'm looking for a corner point and I go to the next corner point, I don't go up, I don't go down. I don't go up and I do not go down, and I go over 1. So this here for the slope will be not up, not down, is 0 over 1. And 0 over 1 just simplifies to 0, right? So you just have to remember horizontal lines have slopes of 0. Well, if that's a slope of 0, then if I want to write my equation, y is equal to 0x, and my y-intercept will be 1, 2, right? So that will be plus 2. Well, 0 times anything is 0, so we can cancel that out and just write y equals 2. So remember, horizontal lines are just a y equals a constant, a number, because the slope being 0, it makes that x disappear, right? All right, what happens for vertical lines? Well, if you don't remember, just try. You go to one corner point, and you go to the next one, okay? Well, you have to go up 1, but you don't go over anywhere, right? So you go up 1, but not over. So your slope here will go up 1, but not over. Ouch, we can't do that, right? That's a big no-no in math. We can never divide by 0. So that means we don't have a slope here. This slope is undefined. We cannot divide by 0. So what do? Well, we're not going to have a y value, but this line definitely, right, because it doesn't cross the y-axis anywhere, this line definitely crosses the x-axis somewhere, and that will be at 1. So we're just going to say this is x equals 1. Everywhere, right? Whatever y value I would pick, the x will be 1. X equals 1, vertical lines are x equals a number, horizontal line are y equals a number, a constant. Okay? From a table, how do I find the equation of a line from a table? Well, if I have a table, then I for sure can find 2 points and do a slope, right? So I could say, well, let's pick 2 points. Does it matter which one? No, absolutely not. So let's just pick those 2. How about that? That's going to be my x1, y1, x2, y2, and let's find the slope. So that will be 0, right? The y2 minus y1, so 0 minus 2 over x2 minus x1, so 5 minus 3. That will be negative 2, and 5 minus 3, 2, so that will be a negative 1. So my slope here will be negative 1. And then I have to say, ooh, but what is my y-intercept? Well, your y-intercept is always where x equals 0, right? Y-intercept is where x equals 0. Y-intercept is where x equals 0. So the y-intercept, if it is when x equals 0, right there it is then. That right there, when x equals 0, that's my y-intercept. So b equals 5. And I can write the equation. Y is equal to negative 1x plus 5. Now, I could also have done the point slope form, right? And I could have just picked any point and use it as a y1, x1, y1, x1, yes. But this one was just as fine because we did have the y-intercept. All right, let's go to the next one. We're given t and f of t. Don't let that bug you, right? This is just going to be your input. That's just going to be your output. So it doesn't really matter the name the letter we're using. It's still going to be your input and your output. Independent variable, dependent variable. wherever the independent variable is 0, that's still going to be my y-intercept, or in this case f of t-intercept. So that's going to be 0, and then I need to find the slope. So I need to look for 2 points, and again, just like earlier, it doesn't matter which two, so we can pick any of those. y2, y1, x2, x1. So m, the slope, will be equal to 6 minus 4 over 9 minus 6. And so 6 minus 4 will be 2, y minus 6 will be 3, and so the slope will be 2/3 here. And the y-intercept we said was 0, so the equation will be y is equal to 2 over 3x and plus 0, but we don't need to write that down. Okay? Parallel and perpendicular lines. So what do we remember from them? Those two are obviously parallel lines. Parallel lines will never intersect. The only way that can work is if they have the exact same slope, meaning they're going to go up and over by the same amount, or down and over by the same amount. They have to have the same slope. So attention, attention. Let's make it happy. Let's smile. Parallel line have the same slope. So parallel line means same slopes. So let's see. Let's check if you can find those slopes. Find your corner, follow the line until you hit another corner, and then count from left toward the right. We are going to have to go up 2 over 1. So this line right there has a slope of up 2 over 1, which is just 2. And then this one, corner point, follow the line until you hit another corner point and count up 2 over 1. So this line also has a slope of up 2 over 1, which is 2. Same slope, parallel lines, okay? How about this one? Well, find your corner point and look until you hit another corner. So follow your line until you're at another corner, and it just happens to be their intersection here. And so, but it doesn't have to be, right? From the point to the left to the right count, we're going to go up 2 to meet the other point and over 1. So this purplish line has a slope of up 2 over 1. Up 2 over 1 is a slope of 2. I'm going to write it as 2 over 1 so you can see what's going to happen. And then the greenish line, when I'm going to go from this corner, follow the line until I hit another corner, which will be right here. From the point to the left toward the right, to meet the one on the right, I would have to go down 1 over 2. So this line has a slope of down 1 over 2. So what do you notice of slopes of two perpendicular lines? Those two are perpendicular. They intersect at a right angle. Notice how this one is 2 over 1. This one is negative 1 over 2. So they're opposite meaning they have different signs, and they're reciprocal, meaning this one is the multiplicative inverse of this one, right? They're the fraction flipped over. Opposite, reciprocal. So we're going to say perpendicular lines, and the symbol is like that, right? Because it shows like a little right angle here. So perpendicular line are opposite, meaning different signs, and reciprocal, meaning multiplicative inverse, right? You're going to flip the fraction over. So then we have to check now. We're given two equations and we want to know, are they parallel, perpendicular, or neither? So parallel would mean we need to end up with the same slope. Perpendicular would mean we need to end up with a slope, two slopes that are opposite and reciprocal. Well, we can't look like that because they are not in the same form. So the first thing we have to do is write them in that same format. So let's do that first. This one is nice. We already can tell that the slope here is a 5, right? Because it's in slope-intercept form. So we have to rewrite this one. So let's subtract 5x from both sides. And remember, we want the x term in front of the constant term. So we're going to sneak it in the front here. We're going to say, okay, it's negative 5x. And we're going to push the minus 3 toward the back. Just push it, don't change anything. Now we're going to have to get y by itself. So we need to divide by a negative 1 everywhere. And so we have y is equal to negative divided by negative becomes positive 5x, negative divided by negative becomes positive 3, and this slope, because now it is in slope-intercept form, this slope is a 5. This one has a 5, this one has a 5, so those two lines are parallel. We can use the symbol instead of writing it in bold, right? That's understood. All right, how about those two? Well, same thing, right? We have to do a little bit of work for both of them actually, because they are not in the form we want. So we're going to get y alone here by subtracting x from both sides. And so y is equal to, you're going to sneak the negative x in front of that 7, but the 7 stays positive, right? Because we haven't crossed the equal sign, so we don't do inverse operation. And we can notice that the slope here is now a negative 1, okay? Negative 1 for this one. How about this one? Well, we want y by itself, so I'm just going to say, hey, I have everything on that side. How about I just move the 3y by adding it to both sides, so I don't have to fuss with those two. So I'm going to have a 3y equals 3x and then the plus 2 there. And now to get y by itself, I just need to divide by 3 everywhere. And so y is equal to 3 over 3 is just 1, so just 1x plus and then 2/3. Well, it is now in slope-intercept form, and I can see that my slope here is a 1, right? When you don't see anything in front of x, it's having a coefficient of 1. So your slope is 1, so m equals 1. Okay, well, they're obviously not the same, right? One is a negative 1, one is a positive 1, so we know they're not parallel. But are they perpendicular? Are they opposite? Yes, negative and positive, right? So they are opposite. Are they reciprocal? Well, let's check. Is negative 1 the same thing, so question mark, as the reciprocal? So sorry, I really don't want a negative there, so I really want just a 1. Is 1 the same thing as 1 over 1? I'm not sure if I'm very clear. So let me change what I'm doing here. I want to be very clear. I want to make sure you're understanding. So we said the slopes have to be opposite. That's kind of obvious, right? Positive, negative. So we know they're opposite already, so that checks, right? But are they reciprocal? We'll write this as a negative, as a fraction. Anything can be written over 1, right? And then write that as a fraction. When you flip 1 over 1, do you get 1 over 1? Yes. Are they opposite sign? Yes. So they are opposite and reciprocal, therefore those two are perpendicular line. Okay. Alright, that's long enough for this video.